Hello, in this lesson we're going to continue scripting our grid layout blueprint that we created last lesson, and then we're going to actually complete it and put it to test in our level. So let's go ahead and jump right back in. Go ahead and open up our BP grid layout blueprint. It's in our blueprints folder, and make sure you're in the construction script tab. Now up until this point, the setup for this grid layout blueprint has been pretty similar to our linear layout blueprint, in that we have a mesh to spawn and we have a mesh width, and then we added some variables for the number of rows and columns. The other big difference, though, besides being going to be in a grid instead of a line, is that inside of our components tab we use an instanced meshed component. So it's going to actually create several instances of the same mesh multiple different times. This is different to how we did the linear layout, in that in the linear layout we were adding new static mesh components every time that we laid out another static mesh in a line. So if we take a look at our blueprint here for our fence that we created, how this worked was, starting at this endpoint, added a new component every time we wanted to add a new fence. So if we drag this endpoint out, basically we just added 2 additional components onto this blueprint. And that works perfectly fine, right? The problem you can run into, though, is if you were to make a really, really long fence or a lot of trees in a row, then you start to have a lot of extra components that the blueprint has to deal with. So you tend to not want to do very many components in a blueprint. You can have several, but let's say you wanted to have 300 static meshes laid out in a row or in some other kind of arrangement. That's probably too many components in a blueprint. So instead, you can use an instant static mesh component, and that will just add instances of your static meshes, and you can do hundreds and hundreds of them without a performance hit. So what we're going to do is use this instant static mesh component to be able to lay out some static meshes in a grid. Now the first thing we need to do is actually set what static mesh we need to use. So if we go into our viewport, we can see there's nothing here. But in our My Blueprint tab, we have a mesh to spawn, and we have our instant static mesh component. So in our construction script, what we're going to do is grab a reference to our instanced meshes component and grab a reference to our mesh to spawn. Then what we can do is take these instant meshes and tell it we want to set its static mesh. Once we've set its static mesh to use, the new mesh is going to be the mesh to spawn. So what this is doing is just telling our instant mesh component, this is the static mesh that I want you to use. Right now we don't have anything selected, but when we go to actually put this in our level, this mesh to spawn variable is public, so we'll be able to set the mesh we want to use there. Now once we've set the static mesh, we need to basically iterate or step through every single row and every single column to make sure that every column is filled with the appropriate number of rows. So how we're going to do that is with what's called a nested for loop. So basically that sounds really complicated, but it's not. All we're going to do is right click, get a for loop, and just the regular for loop, not a for each, just a for loop. And then we're going to right click on this and click duplicate. And then from the first loop, its loop body is going to go into the second loop. This is a nested for loop. So this is going to be a for loop that every time this for loop runs, it's going to run every iteration of this for loop. And it's going to keep doing that again and again and again until the first loop is complete. So basically what this does, and we'll connect our set static mesh to our first for loop, we need to basically go off of the number of rows, and for every row, make sure we have the appropriate number of columns. And that kind of maybe sounds backwards from doing the rows then into the columns, but doing it this way lets us be able to set our X and Y values correctly, and we'll show that in a moment. So let's go ahead and get our number of rows and get a reference to that. And the number of rows, we're going to actually subtract 1 from it. So we can just drag out and get a subtraction node. And this is going to be the final index for this loop, and the first index is going to be at 0. Now the reason we're subtracting 1 and we're starting at 0 is that we're going to use this index number to multiply by the mesh width, and that's how we're going to know the offset from the root of this blueprint, how far off along the rows, and then eventually how far off along the columns we need to offset every instance of the static mesh that we put down. So this is a way for us to know how many along the x-axis, how many along the y-axis, basically how many rows, which is y, and how many columns, which is x, to offset all of these instances so that they end up in a grid. So now that we have this for loop set up, let's grab our number of columns, and we need to subtract 1 from this as well. And you can grab this subtraction node by just searching for the minus sign and drag this into the last index, and first index is 0. So now that we have that set up, what we need to do is, again, this one right here is for our rows. So our rows are actually our y offset. So this for loop, what we need to do is take this index and we need to multiply it, so search for an asterisk, int times float, and we need to multiply it by our mesh width, and this ends up being our y. So let's go ahead and actually right click on that node and place a comment of y, and then click off, so that way we know, okay, this is our y value. Then we need to do the same thing for this loop, drag off our index, multiply, so it's int times float, and the float value is the mesh width, and this will comment this as x. So now we have our y and our x. So what we're needing to do is we need to go in and add an instance. So every time that these for loops run, we need to have a node called add instance. Now when add instance comes up, we want to actually go and find the one that says add instance meshes in parentheses. What this does is it creates a node that is going to actually be called directly onto our instance meshes component. That's why there's no target that we need to actually input here, because the target is built into this node as being our instance meshes component. Now we need to get the x and y coordinates for the transform, not the location, which is part of the transform, pardon me. So we have a transform that we can put this new instance. If we right click on this transform, we can click split struct pin, pardon me. What this does is splits that transform apart into a location, a rotation, and a scale. Now the rotation and scale, we're not going to adjust those. If you wanted to, you could very easily add a rotation and a scale in so that you could actually rotate or scale each of these static meshes in this grid. And I'll leave that up to you if you wanted to add that into your version of this. But we're just going to be concerned with a location. So if we actually right click on the location pin input, and we can say split struct pin again, and this then splits it into an x, a y, and a z. Now the z we don't care about because we want all these grids to be lined up along the z-axis. Now the important thing to understand is all of this data, all of this transform, the location, the rotation, and the scale, is relative to the instance mesh component. So if we scaled that instant mesh component or rotated it or moved it, then it would move every single instance an equal amount of location, rotation, or scale, because this is based off of an offset from the instance mesh component. So now we've labeled this as y, so let's drag this into our y, and we labeled this as x, so let's drag this into our x. Now what we can do is click compile and save, and we're actually finished with the scripting for this blueprint. Well, almost. We need to make sure that this second loop body is actually plugged into add instance. Now we're actually finished, so click compile and save, and let's go test this out. So if we go back to our Park tab, we can grab our BP grid layout, we'll drag that in and let go. Now there's nothing there right now, and that's because our mesh to spawn is none, which is the default. So let's go and kind of pull this out, go into where it says none, click on the little arrow, and we have in here a concrete slab static mesh, so we'll click on that. So we are wanting to use that. So basically able to take these smaller squares of concrete, and we'll kind of pull this up so it's above ground. So now we have this, and it looks like one giant piece. But what we could do is if we take this mesh width, and let's say make it 200, not 20, we can see that we have these in a grid. So it's a 3 by 3 grid. So if I wanted to say, well, I want 6 rows now, it automatically adds 6 more. And you can see that these are all together like this. So it's basically all one instance of a blueprint that has multiple different instances of a static mesh. So let's go ahead and set the mesh width back to 120. And I'm going to make our columns into, let's say, 8. And we're just going to kind of move this to be in this area here. So now I can take this single static mesh, I can have it laid out in a grid for me, and everything is perfectly lined up because I have the mesh width just as I need it for the width of these meshes. So that now we have a large square of our single static mesh, and we can now use this to very easily place many of these in a grid, and we don't have to manually place every single one. So it's a huge time saver. So that's going to be it for this video. In the next video, we're going to get into another use for ConstructionScript, which is working with dynamic material instances.